Okay, today we start our last week of lessons. We're going to talk about a parent function and then talk about how different values on a parent function changes the way the graph looks. Now, if you don't have a blue or a red colored pencil, you can do this in regular pencil. But if you have different colors and you want to use them, you can use them. So, when we did transformations of symmetry, we talked about dilations. And dilations changed how a shape transformed. Did it get bigger? Did it get smaller? So when you talk about dilation of a graph, it tells you how the graph changes in direction. Wider, narrower, and such. Now back in September, we did y equals x, how to graph that. And that's right here. So we're going to start there. The slope of y equals x is 1. But remember, we have to write that as a fraction. It's 1 over 1 because that's y equals 1x. And our y-intercept is 0. So if we come over to the graph and we graph this, we start at 0. And we go up 1, right 1, up 1, right 1, up 1, right 1. Now, if you look at that pattern, it's going to go all the way to the corner and all the way to the corner. You should have a ruler on your desk, and if not, ask the sub for one. And you're going to create the linear equation y equals x. Now, yours should look better than mine because I'm freehanding that, but yours should look similar to that. So if we take a look at this next one, it says y equals 3x. So the only thing that changes here is now our slope, instead of 1, our slope is 3, which is the same thing as 3 over 1. Our intercept is still 0. So what we want to pay attention to is how the graph changes. Is it going to be narrower to the y-axis or wider? So if I come over to the graph and graph 0, 0, 3 over 1 means go up 3, right 1, up 3, right 1, up 3, right 1. Then I can go the opposite way, down 3, left 1, down 3, left 1, down 3, left 1. And then you have your ruler. Once again, your line should look better than mine. And if you notice, when you have a number there next to x that is greater than 1, your graph gets steeper. It's closer to the y-axis. And then last of all, we have y equals 1/2 x. So this time, our slope is going to be 1/2. Your intercept is still 0. We're going to come over here, graph 0. This time, a slope of 1/2 means up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, or down 1, left 2, down 1, left 2. And if you're not doing this in a different colored pencil, that's fine. Just pay attention to what's happening to your line. And again, your line will look a lot better than mine. So the things I want you to pay attention to are over here, what is multiplied by x. So the first note I want you to write, this coefficient is greater than 1. 3 is greater than 1. So this is going to be a steep line. The line gets closer to y-axis. And then down below, right here, this coefficient is less than 1. And what we notice about the red line on the graph, it goes wider. It's a wider line. The red line is wider than the green. The blue line is steeper than the green. So it says the larger the coefficient the steeper the line. So if it's greater than 1, it's going to become a steeper line. So that's our first one. If we go down to the next section, now we're going to talk about a translation. So a translation is going to be a slide. So our parent function, the one we're originally starting, we just did this on the last one. Our slope is 1 over 1. Our intercept is 0. So we come over to our graph 0, 0. We go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And remember, this goes from corner to corner. So you have your ruler. I am freehanding. Your line should look better than mine. There is the line of y equals x. And again, you don't have to have a colored pencil to do this, but it might make it visually appealing to you if you do. So the next one we're going to do is y equals x plus 2. And I'm using blue. This time, there is nothing multiplied by x. So we're going to keep our same slope. This time, our y-intercept is 2. And it says here, this is going to be a vertical shift up. So I start up at 2, and then I keep my same pattern of up 1, right 1, up 1, right 1, up 1, right 1. And then you grab your ruler. You're going to sketch yourself that line of y equals x plus 2. What I want you paying attention to, we'll talk about in a minute. This is a vertical shift up. So the last one in this section is y equals x minus 3. Well, we're keeping the same slope of up 1, right 1. This time, our y-intercept is negative 3, which is going to result in a vertical shift down. So go down to negative 3, and I continue that pattern of up 1, right 1, up 1, right 1. Sketch your line. And again, yours should look better than mine. But here's the things I want you to notice. When you add to your x value, it's shifting the graph up. Okay? When you subtract to the x value, this is shifting your graph down. And these are called parent functions. So this is little tricks to the trade because you're going to be changing the way graphs go. So first was a dilation. Does it get steeper or wider? This is a translation. Does it shift it up or shift it down? And we have one last one on this note sheet. The last one is called a reflection. Now we've done reflections before. Let's start off once again with y equals x. That's our slope is 1 over 1, and our intercept is 0. So remember, that's the up 1, right 1. And it goes from corner to corner. Y equals x will always look like this. Now, another name for a reflection is a flip. Hopefully you remember that from transformations. So the first one here says y equals negative x. So when it's a negative x, not a positive x, that's going to change our slope from 1 over 1 to negative 1 over 1. Which means now my graph is just flipping the other direction. So we start at 0, 0. We're going to go down 1, right 1, down 1, right 1. And then remember, if it's just flipping it, it's still going from a corner to a corner. So your graph completely flips around. So what you need to recall, and look at your notes, when there is a negative here, negative x, it's going to flip directions. So the last one here is kind of putting a reflection and a translation together. Think of what would happen to this if I don't use slope-intercept form, and I just look at what I'm talking about that I showed you. The negative means it's going to flip, and this plus 3 means it's going to shift up 3. So if I start at 0, 0, and I shift up 3, I'm here, and I don't want to go up 1, right 1, I want it to go the opposite, because it has to flip, down 1, right 1, down 1, right 1, down 1, right 1. And that kind of puts that lesson all together. So we're going to use the concepts on this note sheet for the next one. Hopefully you got all that. When x becomes negative, the graph flips.